Good morning, everyone. Today we are going to discuss the topic design consideration for artificial organs. This topic comes under Unit 5 of Biomaterials and Artificial Organs. Artificial organs play a major role in modern healthcare because they support or completely replace the lost biological function. Throughout this section, I will explain why artificial organs are needed, what challenges we face, how designers choose materials, and how testing is done before using an artificial organ in the human body. Before we enter the main topic, let us recall what artificial organs are. Artificial organs are the device created to restore a lost function of our body. This may be mechanical, biochemical, or physiological. Examples include artificial kidneys, pacemaker, artificial skin, and mechanical heart valves. Whenever we design an artificial organ, we must always focus on three important things. First one is biocompatibility. The material must be friendly to the human body. And next one is mechanical strength. It must be tolerate forces and stresses inside the human body. And functional performance. It must perform the job of the original organ accurately. Selecting the right biomaterial is the foundation for safety and overall success. Now, let us understand why artificial organs are higher in demand. Every day around the world, many patients die because they do not receive organ transplants on time. For example, more than 17 people die every single day waiting for an organ. So, as people age, organ fail more frequently and the demand for replacement organ is increases. This situation creates a huge challenge but also an opportunity. Engineered solutions such as artificial organs and bioengineered tissues help us bridge this gap. Before designing anything, we must begin with empathy, understanding the patient's actual problem. We must ask, what does the patient need? What difficulties are they facing? What risks are involved? The first requirement is functional performance. The artificial organ must reliably perform the original biological function. For example, an artificial heart must pump blood continuously. The second requirement is safety. We must minimize immune rejection, inflammation, and infection. The third requirement is quality of life. A successful artificial organ should allow the patient to return to normal living, working, eating, and performing daily tasks without discomfort. After understanding patient needs, we clearly define the engineering requirements. The first requirement is biocompatibility, and then the material should not cause the toxic reaction, allergic, or immune reaction to the human body. The second is mechanical properties. The material must match the strength, elasticity, and flexibility of the native organ. For example, heart valves must open and close millions of times without damage. The third is structural integrity. The device must withstand the long-term stress inside the body without breaking. The fourth one is tissue integration. The surrounding cells should attach, grow, and bond with the implanted material to avoid loosening. The final requirement is scalability. Whatever design we create must manufacturable in large quantities with consistent quality, and it should meet regulatory standards for approval. And in the idea then phase, we think about what material we can choose. One category is synthetic biomaterials. Polymers like PCl, PLE, and PLGA are useful because they are degrade slowly but support tissue regeneration. Ceramics like hydroxyapatite are ideal for the bone related applications. And composite materials combine two or more materials to improve the strength and functionality. The second category is biological scaffolds, and organs are specially prepared natural tissues where all the cells are removed but the natural structural framework remains. And then the third category is surface engineering. We can modify the surface by adding coatings, peptides like RGD or nanoscale structures to improve the cell adhesion, prevent infection, and reduce blood clotting. Choose the right material strategy is a major part of artificial organ design. One of the major revolution in artificial organ design is 3D printing. This technology allows us to build tissue layer by layer with very high precision. Because 3D printing is guided by medical imaging, we can create patient-specific structures that perfectly match the individual anatomy. Bioinks, which contain living cells, are used to print living tissues. These printed tissues can include vascular networks, which are extremely important for supplying nutrition and oxygen. By adjusting the printing parameters, we can control the mechanical and the structural properties of the printed organ. Once we finalize the design and materials, we start building a prototype. The first step is fabrication using methods like 3D bioprinting to build a patient-specific scaffold. Next, we perform cell seeding, and next bioreactor culture, and then we place the seed scaffold inside the bioreactor, and finally we perform validation. This includes testing mechanical strength, biological activity, and functional performance before going for an in vivo trials. And testing is one of the most important stages in artificial organ development. We conduct functional tests like blood flow studies for vascular organization and contractility tests for muscle tissues and fabrication tests for kidney models. Next is biocompatibility testing. We examine immune response like perform cytotoxicity tests to ensure cells remain alive and carry out histological analysis to check tissue bonding. Only after all the tests are passed can the organ move to preclinical stages. And to summarize, human-centered design is essential. We must create artificial organs that mimic natural biological function, durability, and integration. And technological like 3D printing, stem cell engineering, and smart implants are shaping the future of regenerative medicine. Understanding these principles help us appreciate how engineering and medicine work together to solve major health challenges. These are the references I used for preparing this section. Thank you.